Hello, Cougars. In this video, I'm going to go through our vocabulary diagrams and try to explain Mr. Franklin's crazy thinking about how to diagram and explain these things. So the first one is qualitative. Qualitative, I've drawn two stick figures, and it's qualitative is a physical description of something. So tall versus short. It could be red, blue, green, but it's basically a description with words about something we're observing. That's qualitative. Quantitative has a root word of quantity, and a quantity is the name of a thing that we're measuring, like distance. Okay, so quantitative is it's going to have a number. So the root word is quantum. Okay, quantum is a Latin word that means number, has to do with numbers. So it has a number, it's an observation, it's going to be a quantitative measurement. And it's going to have a quantity, and that quantity has a name. So in this case, the quantity is height, because it's the height of the person, which is 1.8 meters, and this person is 1.4 meters. Notice both of these both do the same job as describing what's going on, but depending on what you need, you may need numbers. Sometimes you can't get the numbers, and this is all you can rely on. It doesn't make one necessarily better or worse than the other. It's just how we make an observation. So the best way to think of precision versus accuracy is precision is I'm going to do things the same way every time. So if I'm shooting hoops with my friend and I'm shooting basketball, if I hit the little corner of the square that's on the middle of the backboard but I miss every time, I'm precise. I'm going to hit the same mark every time. Now, accuracy is actually getting the right answer, getting the correct value. So I could shoot a basket and make one basket. That's accuracy. Now, if I shoot 100 shots and I'm precise, but I don't make anything, well, then I'm not accurate. If I only make one basket, I'm at least accurate. Now, what's the goal? Is to be both, right? We want to be precise. We want to hit the same thing every time, and we want to be accurate. So that's precision and accuracy. So what this is saying is I've got a person that's 1.8 meters tall. They are actually that height, but every time this is what I measure. They're close to the same measurement because I've done it the same way every time. It's off, but it's the same. This one is 1.8 meters actual. Well, one person measured the actual value, okay? And this is really important when we're looking at our lab data to describe, do we make a mistake? And how do we talk about mistakes and finding mistakes and that kind of a thing. Independent variable. We shortcut independent variable to the letters IV, and dependent variable, we shortcut to DV, okay? So how this works is independent variable is an input or a cause for an experiment, okay? So if I'm going to measure a plant and its growth, I'm going to input sunlight. That's what I'm going to test, okay? And then I'm going to experiment and see what is the output, what is the effect. So the independent variable is the input, independent input to the experiment. The dependent variable is the output. It's the effect because it depends on what the cause was, okay? So dependent variable is what's the output of the experiment. Okay, so when we're setting up an experiment, we'll talk about things called a control. So if we have two sets of experiment, I have an independent variable that goes into the experiment, and I'm going to produce a dependent variable. If I control things, so for example, growing a plant, if I'm testing fertilizer, that's my independent variable. What's the control? I'm going to control sunlight. I'm going to control temperature. I'm going to control the soil. All of those controls are going to make sure that I'm only testing this cause. Does the fertilizer actually work? And that way my output, I can know, well, it was only this input that we were changing, so I've only got this output to compare and analyze. However, if I'm changing the sunlight, changing the water, changing the fertilizer, and I'm not controlling those things, I'm going to get all kinds of different dependent variables, all kinds of different outputs, and I'm not going to be able to tell what's going on. So we're going to control the experiment. Next, we have hypothesis. And you've heard this before, it's an educated guess. It's a better way to think of it, like kind of like the video. We're making an observation, hypothesize. So we're going to predict what's the independent variable and what's the result going to be. So a hypothesis is a predicted experiment that includes the independent variable is going to be done in this experiment and it's going to cause this result. So the independent variable is going to cause this output, and it's our predicted guess of what that result is going to be. Okay. When we do analysis, we're going to examine the independent variable, make sure we did all our measurements, errors, all that kind of stuff, but we're also going to examine the output, and then we're going to discuss it. And in our discussion, we will find out, well, did we figure out something? Did we not? What did we learn from this? Okay, we're going to come back to those later. No, we're going to do those now. Okay. Now, the next thing gets confusing very quickly, and I think we should actually start with the idea of quantity. I've already mentioned it once before, but quantity is the name of a thing we're measuring. So distance, time, okay? That quantity has a way that we represent it for our math, and that's called a variable. So distance, d, time, t, okay? So magnitude is the number size of a measurement. So the quantity here would be height, because that's an h. The variable would be h. The quantity, the magnitude would be 1.8, and the units would be the meter. Okay. So when I say quantity, I'm talking about the thing the name of the thing we're actually measuring, the name of the type of measurement. The variable is a math symbol we use to represent it. Magnitude is the actual number, and the units is the measurement. And the unit of measurement is always tagged on after the number. Okay. Next, kind of underneath our table of quantities and stuff, we have these two words, initial and final. And today you're going to learn about how to do this kind of diagram. But literally, initial means beginning. It's the first one, okay? Now, we might do DI to mean initial. We might do D1 for initial. And we might number it all kinds of things. Just know that it's the beginning. So we will also do something called D0, because it's the starting condition. At time equals 0, we might call it D0. But this, and this can mean the same thing. We just have to be careful and make sure we're using our context clues to make sure we understand. But initial literally means the beginning of our story, okay? Final, guess what, is the final, it's the end, okay? Now, we can also use D2 because 2 happens after 1, but we could use D1 because 1 happens after 0. Bottom line is I prefer DF many times because it just tells me it's the end of things, okay? And I think that'll make a lot more sense once we start drawing. That's a brief overview of our quantities and units. Please study those. That's all I've got. Thank you for watching, and I'll see you in the next video.